Let's take another question. You are given 1, 0, x is equal to 2 is a 0 of the cubic polynomial 2x cube plus x square minus 13x plus 6. Find all the zeros. Means find the remaining two zeros if they exist. There are 3 zeros maximum possible for a cubic polynomial, you have seen. 1, 0 they gave. So as we did earlier in the previous question, what do? You diminish the given cubic polynomial by using the given 0. Means reduce by 2. Actually you are dividing by x minus 2. Long division method you can use, but this is more easier for you. Synthetic division we have done before. How to diminish by 2? That coefficients of the given polynomial we have to write here as earlier we did. 2 and here 1 and minus 13 plus 6 all the coefficients, and the 2 we write here. First we put 0 here, adding them you get 2, then this 2 into 2 is 4, add you get 5, and multiply this 2 into 5 10 right here, add it you get minus 3, again multiply this right here, plus 6 minus it becomes 0, this term will vanish here. Okay, now you are getting only 3 things, 3 numbers. This will be the coefficient of x square, it will be coefficient of x, the constant term. Right, this quadratic polynomial. Your cubic polynomial reduced to quadratic now. So it becomes what? 2x square plus 5x minus 3. Okay, you got this. This one you factorize by splitting middle term method. You get 2 linear factors. Here it is done. Already explained many times. You are very familiar with. So you are factorizing what we got, a quadratic polynomial. You get 2 linear factors. Okay, one is x plus 3 and 2x minus 1. Each linear factor as usual we equate to 0. When I equate x plus 3 to 0, I got x is equal to minus 3. Like that, 2x minus 1 equated to 0, I got x is equal to half, 1 by 2. So your zeros are, zeros now. So what is that? X is equal to 2, minus 3 and half. These are the 3 zeros. This 2 is the one they have already given. The other 2 are the ones we found. Right, we have to list all the 3 zeros. These are the new zeros we found, this is the one given. Okay, this is how we have to do it. Okay, next we will move to biquadratic polynomial, 4th degree polynomial. You know, biquadratic polynomial will have a maximum of 4 zeros. In this type of questions, they will give you 1 0 or 2 zeros and ask you to find the remaining zeros. So I taken one question, some example question I taken. See, look here, this. Find all the zeros of x power 4 minus 15x square minus 10x plus 24, a 4th degree biquadratic polynomial. Maximum 4 zeros will be there. If 2 of whose zeros are 1 and minus 2, they gave you 2 zeros, okay? The remaining zeros, if existing, we have to find. This is the question. So how to find it? So what you do, they have given you 2 zeros now. You form a quadratic polynomial with those zeros. That quadratic polynomial will be a factor of the given polynomial, given 4th degree biquadratic polynomial. So how to form a, already you know that, how to form a quadratic polynomial whose zeros are given. We have done it earlier. So we form, how, you know that, k into x square minus alpha plus beta x plus alpha beta, we done before. So I use that formula and find out k into x square minus of, this is minus, these are the things given, minus 2 plus 1 x plus minus 2 into 1, alpha plus beta x plus alpha beta. Okay, this k you take it as 1 here, any value. So k is 1 I have taken. So I got here x square plus x minus 2. I got a quadratic polynomial whose zeros are the given zeros. Okay. Next what you do, divide the given polynomial by the quadratic polynomial you made out of the given zeros. using which method? Long division method. So long division method are done here. See, look, take care here. X power 4, then x cube term is not there. Either leave space or you have to write 0x cube. Then minus 15x square minus 10x plus 24. Here is a quadratic polynomial we made. We are dividing here. I think I don't have to explain again and again this long division. You are already familiar. Here are divided. You can do yourself. You can cross check with from the video clip. So here I divided. The remainder will become 0. As I told you, this quadratic polynomial you made will be factor of the 4th degree or biquadratic polynomial, given problem. We divided and we got this quotient, a quadratic quotient. You get a quadratic polynomial as a quotient. Okay? Right. This now take this quadratic quotient, take it here and factorize using splitting middle term method as we do earlier. So I have factorized it. Okay? Factorize by splitting the middle term. I got two linear factors. Each linear factor equal to 0 as we did earlier. So you got x is equal to 4 and x is equal to minus 3. Two new zeros came. Okay? 4 and minus 3. The given zeros are 1 and minus 2. So totally we have 4 zeros here. So list all of them together. The zeros are 1 and minus 2. What is given? And minus 3 and 4 we found here. Minus 3 and 4. All 4 zeros are listed here. So if 2 zeros are given, what is the method? You make a quadratic polynomial with the given zeros and divide the given polynomial by the quadratic one you made. You get a quadratic quotient. Factorize. Okay? And get 2 more zeros from that. This is the procedure, right? Yes. This is another question from your textbook, exercise 2.3. Question number 3. Obtain all the zeros of 3x power 4 plus 6x cube minus 2x square minus 10x minus 5. If 2 of its zeros are square root of 5 by 3 and minus or square root of 5 by 3, negative of square root of 5 by 3. 2 zeros are given as we did in the previous question. Okay? When you form the quadratic polynomial with the given zeros, here x term won't be coming. That is why this question I have taken. So now, as usual, what we do, we are making a quadratic polynomial with the given zeros. That is as usual, that was k into x square minus sum of 0x plus product of zeros. Okay? This becomes 0. So 0x. So k into x square minus 0x minus this, when you multiply, what comes? Square root will go 5 by 3. Negative 5 by 3. Okay. Here you can take k is 1, no matter. But you can take k is 3. If you take this fraction, will get cancelled. Okay. This is no matter. If you take k is 1 also, you can divide. This is not a problem. So I have taken k is 3. So it will become 3x square minus 0x or plus 0x, no problem, minus 5. Okay, we got this quadratic polynomial with the given zeros, root of 5 by 3 and minus of root of 5 by 3. Now next, what we have to do? The given polynomial will be divided by the quadratic polynomial we formed. Here is the division, long division method you apply. So you divide. Okay, while dividing you get quotient x square plus 2x plus 1. This quotient you get. What's the next job? You have to factorize the quotient, the quadratic quotient, factorize to get 2 more linear factors. So we are getting here factorized. You can use splitting middle term or you can use the identity. This is actually a plus b the whole square identity to work with. So you can factorize how I want. You get 2 same factors, x plus 1 and x plus 1. Each factor equal to 0. So you get what? X is minus 1. Again if you equate this, x is minus 1. Two zeros. Both are nothing but same number. So minus 1 and minus 1. Two zeros. Originally given zeros are here. Okay. These are the two zeros we found. Totally 4 zeros we have. So the question asks you the other zeros. I wrote the other zeros here. Okay, is that clear? So similar to this one question is a short example in your textbook, that is page number 35. Take example 9. Same question. You can do it by yourself without seeing the answer over there. Yourself you solve. Okay. Alright. Let's move to next question. Question 4. In that question, they have given, that question says that, on dividing x cube minus 3x square plus x plus 2 by a polynomial g of x. Okay, we divide by polynomial g of x. The quotient and the remainder are minus 2x plus 4. Quotient and remainder are x minus 2 and minus 2x plus 4. So what are the things are given? They have given a dividend, a divisor, what they are asking you. Quotient they gave you, remainder they gave you. Alright? So there are four things, they are connected by division algorithm for polynomials. What is that? Gx into qx plus rx is equal to bx. Means divisor into quotient plus remainder is the dividend. No. There are four items. They may give you any three, you find the fourth one just by transposing. Here we do not know what is the divisor, gx, we don't know. Rest of the three things are given. So substitute here. So gx into qx plus rx is equal to bx. You want gx, so transpose is rx other side. So you get px minus rx. Then transpose this quotient also, qx other side. So when you transpose, you get gx is equal to px minus rx by q of x. Okay, subtract the dividend minus the remainder, given remainder that is subtract here. Then divide by the quotient. So here subtracted and division by quotient. Division you can do any method. You can do by synthetic division, by diminishing by 2, or you can do by long division, whatever you want. Divide this x cube minus 3x square plus 3x minus 2, divide by x minus 2, the divisor denominator. So you are dividing here. So you are getting this quotient. Okay, x square minus x plus 1. That is what g of x is. That is the divisor. So of the four things, divisor, quotient, remainder, dividend, all these four things, they will give you any three. You have to find the fourth one just by transposing. Is that clear, that question now? Like that. Yes, this is question number 5 of the same exercise we would like to do now. The question says that give examples of polynomial px, g of x, q of x and r of x, which satisfies the division algorithm and the condition. It is a condition given. It should satisfy the division algorithm. You know the division algorithm. P of x is equal to g of x into q of x plus r of x. Means dividend is equal to divisor into quotient plus remainder. This algorithm it should satisfy. Such polynomials you have to give examples. There is one more condition here. When you give your examples, the degree of p of x and the degree of q of x, means the dividends degree and the quotient degree should remain the same. Any example? Condition, dividends degree and the quotient degree should remain the same. Okay. So what you have to do here? See, one of the questions we have done before, just I show you what change is taking place when I am dividing a polynomial by another. Let us see this example we have recently done. See this example. X cube minus 3x square plus 3x minus 2. I divide by x minus 2. What change is taking place in the quotient and its degree? Look here, here degree 3, here degree 1. When I divide, what is the degree of the quotient? It is 2. Means this degree, what this degree 2 is coming from where? This 3 minus this 1. That is what you have here. So by which polynomial you are dividing? Okay. The dividend degree minus divisor degree will be the degree of the quotient here. Okay. Now come to the condition here. The condition says the dividends degree and the quotient degree must be same. There should not be any reduction. You can't subtract anything. So what does it mean? What do you understand from that? I want the dividends degree and the quotient degree must be same. So what I have to do? I must maintain divisor's degree what? Because dividend degree minus divisor degree only the quotient's degree, right? So you should not subtract anything, means the divisor's degree must be 0. If you are dividing this polynomial by any constant polynomial, a polynomial of degree 0, then this x cube only will come here. Same degree. Degree of dividend and degree of quotient will not change, provided the degree of divisor must be 0. Mean it should be constant polynomial, right? Okay, now come to the point here. So you take any polynomial, alright? They are asking one example. You give your own example, doesn't matter, any example. I have taken a linear polynomial, easy way, okay? I take a linear polynomial, 10x plus 4, degree 1. Okay? So now what I told you, you take the divisor as a constant polynomial. So I take divisor as 2. I divide 10x plus 4 divided by 2. No need to do long division. This way you can take the common factor out and simplify. You get the quotient here. Or divide like this. Whatever the way. What happens now? Dividend 10x plus 4. Quotient 5x plus 2. Here what is the degree? Degree of dividend 1. Degree of quotient 1. The same degree. So if you divide any polynomial with a constant polynomial, there will not be any change in the degree of quotient and that of the dividend. This is clear now? This is what we are doing here. So you take any polynomial, let it be a quadratic polynomial. Take always the divisor, a constant polynomial. Your quotient will be having same degree as the dividend has. This is what the example question is asking for. Let's move to the next question. Same condition, same thing they are asking. But this time the condition they have given you, degree of quotient and remainder. Degree of quotient and remainder should be same. This is the condition, okay? So what you do, when this is possible now, you take any polynomial as a dividend. Okay, let us be little larger degree. For this condition, you should have the px and gx. The dividend and divisor should have a greater degree than this. Or that what you have to do, that degree of quotient and remainder must be less than that of px and gx. Take any, no matter. You take here p of x, I took one cubic polynomial. Divisor should have lesser degree, then only we can divide. So I take the degree of g of x, quadratic I take, okay? Here maintain one thing. Typically here what is x cube plus x square plus x plus 1. Here you just leave the x term, okay? Take x square term and a constant term only, but quadratic, right? Divide, what is happening you see now. Divide by long division method. Here divide. As I told you, x cube plus x square plus x plus 1. Here dividend, the divisor x square plus 0x, no x. I told you, you leave the x term and write the constant term. X square plus 0x minus 1. Now you divide by long division method. What is happening? I got the remainder here what? 2x plus 2. Now the quotient is x plus 1 I got. So quotient is x plus 1. What is the degree? 1. It's a linear polynomial. remainder degree 1. Both are having same degree. So you take the dividend as a cubic polynomial, divisor as a quadratic one. In that, just leave the x term, only x square term and constant term you take, you divide, you will get what? The quotient degree and the remainder degree same. This is what the condition, the question is asking for. It's clear now? Any example, any other example you can take and try, no problem. Okay, this is our own choice, we can give any example. Let's go to the third question. Third question is the continuation of the same question. The third bit says condition degree of r of x is 0. Means the reminder's degree should be 0. Means the remainder must be constant. Any constant, no matter. So what do? You take the dividend as quadratic polynomial, divisor, g of x, any linear polynomial take. Divide. Take a quadratic polynomial, divide by the linear polynomial. Okay? Quotient will become linear, remainder will become constant. So divide and see now. Any quadratic polynomial here. So I have taken here is a change here. This is x square plus 6x plus 10. We change the question. X square plus 6x plus 10. Anything, any quadratic polynomial we are taking. Divided by g of x to linear, x plus 2. Okay. When I divide by long division method, quotient is this. What is the remainder here? 2. Remainder may be 0, 2, any constant here. Always constant polynomial will come, constant. Okay. What is the degree of this one? 0. So, you are getting here remainder. I have got remainder, degree of remainder I got 2, a degree is 0. Degree of the remainder 0. This is what the question. These are our own choice. We can take any example and try. This is question number 5. It's the last question in that exercise. Okay. And we have to discuss a few more example and exercise questions. And I will be giving you some homework. You take homeworks from your textbook this time. You take that question number 4 you take. From exercise 2.4. Exercise 2.4. It's an optional exercise. And question number 4. Do it. A similar question I have already explained you. This question do it yourself. Okay. Then at the end of the lesson, there's one more question to discuss. And then I'll give you a worksheet to solve by yourself. Okay.